everybody, my name is Sally-Ann Spence and welcome to the Hills Quarry Products dig site in Surney Wick, where we have material from both the Jurassic and the Ice Age. This is possibly the biggest paleontological dig in the UK at present. Now we have paleontologists here, we also have geologists. One of those is sat next door to me now. His name is Steve Cousins. Hello Steve.
G'day Sally-Ann.
You are also known as the Rock Showman.
That is correct.
But you are a geologist and an earth scientist, aren't you?
Yeah, I put the two together because I love rocks, but ultimately the reason that we look at rocks is because they can tell us the story of our planet, the Earth.
Well, do you know what? That is very true. And we've been using a geologist to help us tell the story of the site here, which is really complex, actually, in many respects. You have also been here helping us at the dig, actually taking part in the dig, but also helping us because you've bought a large big top, which we've been able to use as a social space. So I'd like to say thank you to you.
It's been a pleasure.
For providing that facility.
Yeah, it's been a pleasure to bring the two sides of what I do together, the rocks of geology and the showman as well. So the big top has been here as the cultural centre. We've all been enjoying that for the lectures and the space that it's allowed us all to give a little bit more in our presentation for whatever it is that we're sharing with each other. It's been a great focus.
It really has. So, you know, as I said, a big thank you for that. That's really important that we say that to you. Now, rocks.
Yeah.
Come on, let's go talk
All
about
right,
rocks.
let's get into the show, man. That's what it's about here.
Right.
Yeah.
Where do you want to start?
Well, why don't we start in the middle, because here is a rock which has come directly from this site last year.
Oh, right. I've got Mark helping us with the camera. Mark, can you bring the camera in and show everybody?
Great. There, get in and have a look at this guy. Now, this has been polished, as you can tell, so it's nice and shiny.
Beautiful. And
this is what we call a septarian concretion. Now, someone's going to ask, but what is a septarian concretion, Steve?
I have. What's the stop? I can't even say it. What's the septarian concretion,
Well,
please, Dave?
I'm glad you asked there. I'm right on cue as well. I'm not going to say this is, but clearly it is one of these here. This is, let's start with the second word, concretion.
Yes.
The name kind of gives it away what it is. This is like a bit of concrete. It is a harder rock that is formed in the sediments when the rocks here were still squishy bits of sediment down at the bottom of the sea around about 165 or so million years ago.
Right, okay.
So something happened to this particular part of that seabed, and there's a little bit of evidence as to what that might have been. There's some organic material that sank down to the bottom of the sea. Now, what could that be? This is a whodunit mystery here.
Right, okay. That's quite exciting. So organic material.
Organic material, it's come from life.
So you're saying it's not natural animal, it could be something that the animal produced?
It could be either of those things, and there'll be evidence of it in the rock.
Right.
Now, if we look closely, we're not seeing in this one, we're not seeing an ammonite shell, we're not seeing any other kind of shell that we can identify there. We're not seeing bones, but we are seeing a very interesting colour, this colour of orange. So
well, we might get, Mark, can we get you to bring the camera back in so people can see this?
Go on there. It is an important colour here because it's giving us some indication of the chemistry of the bottom of the sea. And it's this colour here, this tan kind of orange there. I suspect that colour is going to be coming from a little bit of poo. Oh,
fantastic.
Yeah.
So we're talking coprolite.
We are talking coprolite, indeed. This coprolite here, the chemical is likely to be some kind of phosphate, and the only way we get phosphate in this system at the bottom of the sea is coming from the poo that something has dropped down to the bottom of the sea. We don't see a lovely shape. We're not seeing something that is really going to go us a nice poo shape. This is kind of a splatter poo if we really go into the details of it.
Does it tell us any contents in the poo?
If we look in there under a microscope, we might be able to see things, and I'd be looking for things such as little black, essentially they're going to be fish bones, they're going to be teeth, they're going to be, they tend to be black in this environment.
Right.
Under my lens, I've not seen that, and I've not actually done any detailed microscopic studies of this,
Right.
but that's what we'll be looking for.
That's brilliant.
So,
that's really exciting.
So that's the second half of the word, the coprolite, the concretion. The organic material from the poo, it started to break down, and we get this bacterial reaction which leads to different minerals kind of clogging together down at the bottom of the sea. And that has formed the concrete part of the concretion.
Right.
That's step number one.
Okay.
Okay, step number one, change of minerals because of this organic breakdown. Step number two, we don't really know exactly how this happens, but essentially as more pressure builds up, as sediments build up higher, this concretion then started, with compression, cracked as water came out of it.
Right, so that's what these are then, is it?
Exactly, these big white lines.
But I was going to say they've cracked, but they're filled with this white material. So what's this white?
Great, so that's step three of the process. Later on, after these cracks have formed, you've had another lot of mineralized, mineral-rich water flowing through the substrate underneath the sea, and that is then filled in these cracks and left the mineral calcite.
So that is calcite.
So
right.
we got poo, we got cement, we
all
got
going on
cracks, and then we've got mineral on the outside.
Do you know what? That's fantastic.
It's a story,
That's
isn't
a
it?
very exciting rock
There's a
isn't it?
lot going on there. It's beautiful. Well, for me, it is beautiful, but it's also got this story as well.
Do you know, I think that's brilliant. Absolutely brilliant.
Another little thing I love about this one, you shine an ultraviolet torch on that, which we can't do now because it's daytime. You'll get a lovely fluorescent reaction of that calcite as well. So you get a real, this goes nicely in an ultraviolet display as well. For those people out there who like to collect things for their different kind of collections, you can have one of these in your poo, in your rock, and in your UV collection. That's a 3-in-1 right there.
It's a 3-in-1. Wow. I mean, it's just, can I just pick it up?
You're very welcome to.
Because I just want to turn it round. It looks not that exciting from this side, does it? And that is a totally different thing when you, get inside there and then have it explained to you. That's amazing.
Yeah, and these are all the way throughout this quarry here. They're actually from the Oxford clay, which is just above the Kelloways Formation, which is the rocks that we're actually digging into here. But they have washed into this Pleistocene river system, this Ice Age river system. They've washed into here, so we're getting a lot of them. Some of them are full of fossils and some of them are full of poo, and yes, you can polish a turd. You've seen it here first.
Right, okay, so I've got to follow on from that now. We are videoing these, or we're filming these live, raw and unedited from the field, because we cannot have everybody come to this site because we're in a working quarry landscape. But we want you to enjoy the dig with us, all the excitement with us, and meet everybody who's involved with it. So bear with us, because as I said, we are live and unedited.
And
Steve.
raw, okay.
And raw. Right.
That was the raw bit, to be fair.
That was the raw bit.
Should we talk about another?
Yes.
Let's look at a fossil.
Let's
okay.
go have a look at what
All
we've
right.
got here.
Normally in my show, I have my props ready to go, and today I've brought my prop. Here
Oh,
it
look
is,
at this.
ready to go. So this is a propennulites, a macroconch. Now that means big shell, macro, conch, put those two words together, that's what it means. Now I'm going to tell you something not just about the propennulites, but about the macro and the micro conch. So in ammonites, we get this thing which is called sexual dimorphism, and basically that means that there's a range of sizes between the genders within the same species. A macro conch, we think, are the females. And some theories around that, and none of them have been proven, so there's still studies going on, but we think that maybe the macro conch, maybe the females needed to have more room for their eggs or for the reproduction purposes. So often we get a really big one and we go, there's a good chance that that's a she,
Right.
she, her right there. So she's a beauty. This is by no means a museum quality piece, but it shows just the type of the big ammonites that we are finding on this dig. This one came out last year and it's been prepared, so you can see both sides of this one, but I won't bother turning it around. You're seeing the pretty side there. Let's leave the good face to the cameras.
That is absolutely beautiful.
So normally at this point someone says, but what is a propennulites macroconch?
What is a propennulites?
Just
I've
like-
got to say the word, haven't I?
Just like we
Macroconch.
rehearsed. So
Live and unedited.
it is raw all the way through. This is an ammonite. For viewers who are watching in England and for Britain, you're probably familiar with ammonites. They're very, very common throughout the rocks here because the rocks of a lot of England is from the era where there are lots of ammonites. These guys were swimming around in the sea, or these girls were swimming around in the sea, and they're very closely related to an octopus, although they had a shell. So they're a cephalopod mollusk. That means they're related very closely to creatures that are alive today. octopus, squid, nautilus, and cuttlefish.
Right.
So that gives you an idea of
So we're talking
what the creature
tentacles,
was.
aren't we?
We're talking tentacles, 12 ticles. We're not quite sure exactly how many, but there were definitely lots of little arms coming out with suckers on the end. And like the nautilus, who these were cousins of, the creature would have been able to retreat into the shell and specifically into the body chamber, which is this probably last 2/3 to 3/4 of the shell would have been open all the way to the back where the first septa wall of the shell would have been. So they're an ammonite, very common throughout particularly the southern half of England. Draw a line from the River Tees, go all the way down to the River Exe, and everywhere south and east of that you get lots and lots of ammonites. So that's a beauty which has come from last year and now tours around with me as the Rock Showman as I do my educational outreach, telling stories about rocks to people like you're getting right now.
It's fantastic. It's fantastic. Right, okay. To top that then.
Top that, well, I thought we are down here in Gloucestershire. Now, for anybody who's American or Australian, that is Gloucestershire for you all. And here's another beauty that comes from not this quarry, but from around about here. These are an echinoid. That means they are related to things like starfish and sea urchins and sand dollars and sea cucumbers and all of the other kind of brittle stars as well. But in this case, these echinoids are essentially a sea urchin.
These are beautifully preserved, Steve.
Aren't they lovely? They really are one of my favourite fossils that I've prepared myself. And what you're seeing is, we call it the test, and it's essentially the shell of the urchin, just like you'll find washed up on a beach around the world today.
Would these have had spines?
These would have had spines, absolutely.
And the spines presumably a tiny drop off, disappear?
Exactly, you can find them in the fossil record as well, but in this case they haven't preserved attached. And this is called the test of that part of the shell is called the test when it comes down to a sea urchin, and I will be testing you later to see if you remember that.
And you probably will, knowing you, yes.
Yeah, and now these have got a lovely little story to them. So as we've gone forward in time, we use science to explain things, but previously we've used stories to explain why these things are here and what they are. And now we can say that is a Clypeus plotti, but let's ignore the noise that a horse makes when it runs along a road. What we can also call these is a pound stone.
Yes, yes, I've heard them being called that before.
Normally somebody at this point asks, Steve, why are they called a pound stone?
Steve, do tell me, why are they called a pound stone?
Good at this, look at that.
Getting better.
All right, so they're called a pound stone because back in the days before we had access to everybody had access to a scale, these were actually used as a pound weight. They were fairly regular in size, but if you look at this, you can see that the difference between that pound and that pound is kind of the difference between a Big Mac when you see it on a photograph and a Big Mac when you get one, okay? So quarter pounder over here on a photo, quarter pounder here. Well, there's the reference that we got for that one.
Okay, that's quite a good reference.
So personally, I don't think that they were a very good unit of measurement back in the day, but this is how they would weigh out butter at a market. You would have a couple of pound stones and you would get your couple of pounds of butter as well.
Interesting. Right. Very
so
good.
They're here just as a sample of the wider Gloucestershire for those not from around here, and some of the fossils that we get in the similar Jurassic rocks. Wherever you are here, whichever layer of rock you're in, it can be really, really different. We've got some of the environments are marine, some of the environments are terrestrial, some of the environments are fresh water, and therefore the fossils are going to be really, really different.
Yes.
We're just seeing a very small window into the Kelloways rock formation directly on this site with a little bit of the Oxford clay thrown in as well. But even just a few miles either direction of here, we get a whole bunch of really different rocks and minerals coming out of the ground.
We are very lucky in the UK that we do have a phenomenally diverse sort of bands of rock and everything, don't we?
And as an Australian, I've got to say that ours is better. but yours is more
beg to
compact.
differ.
It's more compact, and that's it. Australia's an entire continent.
We don't have to travel so far
Exactly,
for each one. That's
exactly.
what it
I mean,
is.
personally, I drove 5 hours here, which all the locals will be, you what? You came all of that way across the country?
That's nipping to the shop for you
5
normally,
hours.
isn't it?
I mean, I can do that in 5 hours. It's literally that far away. But the British Isles has an amazing density of variety in geology, and that's part of the reason why the science was founded here. The scientists in the early days, in the 1800s, could really see the simplicity, but also be able to understand the story and infer it.
Yeah.
And it was particularly simple. It's nice and layered in most of England. You know, all of the east and south of England is quite organised, sensible, very British layers that sit neatly and politely, one on top of the other. If you look at them all together, you can start to map them out, and that's what was done in the 1800s. You get to places like the Lakes District and Scotland, it gets more complicated, but then the brains started to work out why that was the case as well. But we're not going to go into that story today because we've only got so long to be
I'll ask you
live,
to describe the
raw
geology
and unedited.
of Arran, the Isle of Arran at this rate. So, you know.
Scotland in an island,
Yes,
let's do it.
Exactly. No, they're fantastic. So have you brought anything else to show us then, Steve?
Well, actually, I do have one more here, which actually I was going to bring into this story, but I forgot.
Ooh.
So this is just a lovely little bit of calcite and limestone, which tells a little bit of the story.
Mark, come and show people this.
Let's bring it in here.
It's in
Okay.
its crystal form, and it's like that. It's just lovely, isn't it? Tell us a little bit about this piece then.
Well, I guess the story that this one is going to tell you is if you look at this on the side, you'll see that this is just limestone. Then if you look at it, if you're looking along the side, you can see that I've polished the limestone there. But then if we're looking at on the lovely face which is being displayed here, you'll see the beautiful crystals that are coming out of this as well. So limestone and calcite, one of these great mineral rock combinations that can constantly change their form, essentially. Limestone dissolves in water, particularly if the water is slightly acidic, and most water is naturally acidic. So when the water table fluctuates and goes through limestone, it will naturally dissolve some of the limestone, which leaves a hole, i.e. a cave system, but also it takes away in its water that dissolved mineral, which can then later precipitate to form these crystals. So that's the process which was also going on inside this septarian concretion. And you can see in here again that we've got tiny little crystals which are growing into the center of a void. When we find a sedimentary rock, if there's crystals there, then there must have been a space for those crystals to grow into, at least when it comes to this calcite that we're seeing here now. So that's a general rule of...
Because you sometimes see them growing in body chambers of ammonites and things like that, don't you?
Yeah, and very much from this site, if I had a cadoceras, I would have been able to show that exact same thing. The cadoceras are a beautiful cannonball. We use, for those who've been following all of these live, raw and unedited...
I do have one. Hang on,
Oh,
we are live,
okay.
raw and edited. Mark, if you look just down below the table, we've got lots of different samples here. I do think we have one. We might be able to find you one.
There we go.
Look at this.
Beauty.
We have a beautiful
All right.
one. There's
Look
Mark
at that.
modelling with a cadoceras.
It
Thank
matches
you, Mark.
your shirt, Mark. That's lovely. Look at that. So the cadoceras is a bizarre, in my mind, a very bizarre ammonite because of its shape. I really try and think how was that stable in the water as a cannonball, but apparently it was because it survived for a few million years. But we're getting into the story of calcite now. All of the center of the inside of this will be solid calcite.
Oh, really? Right.
Absolutely
yes.
solid inside here. And this was, as you know, this was a shell filled with chambers. And those chambers, actually when it's alive, was air.
Right.
And the way that these creatures, the ammonites, would swim and change their buoyancy in the water was pumping air or water in and out of their chambers, so
Right.
it would go up and down.
Steve, I have had one question
Okay.
asked to me many times, and I'm putting you on the spot here. I've had many people say to me, you say that they're pumping themselves full of air and yet they're in the sea.
Yeah.
How do they do that?
They're very clever. Yeah. God is full of surprises. Is that the answer?
No,
Of
but
course
we'll go
it's
for it.
not. Well, they're mostly pumped. They will be able to have air through the breakdown of their processes. They will fart essentially when they are consuming. When they are breaking down organic material themselves, there's going to be waste products, and some of that is going to be gases. So let's use the term gases rather than air, and maybe that is more technically correct. So they can retain some of that inside them and help them go up and down. Essentially, they're pumping water in and out of the chambers,
right.
and the water will also, through a siphon, will allow them to propel themselves as well.
Okay.
But I think the real story with these ones, and we'll try and get a sample that we've cut open or polished. I don't know if there are any on site, but if you look at polished Cadoceras on Google, do it now. Great, you've got it. You can see it now, can't you? There's the example of this, where every single chamber has been completely filled up with calcite to show really beautiful lines. You're loving those lines, aren't they? Really,
Okay.
They're called sutures. They are absolutely stunning on this particular genus of ammonite. So that shows that the minerals can be in solid form, but they can also move throughout the substrate over geological time, and then fill in cavities to end up with beautiful lines and structures and definitions. So that's, I think, all of the rocks that I'm going to show with you guys today. But of course, if you want to follow me, you can see at the Rock Showman, and I will tell you lots of stories of rock nerdery.
Well, on that note, Steve, thank you so much for telling us about all of these. I love this. This is so up my
It's
street.
pretty,
Absolutely fantastic. You look at something, as I said, you know, that just, this is the joy of fossils, isn't it? I mean, that just doesn't show you much at all. You could possibly overlook it and almost sort of not worry about it at all. And then you've got this inside, and then that amazing story that's connected to what's going on in here as well. Fantastic.
Yep, and there's 1,000 of them on this site, and only a few hundred of them have been broken open, and not many of them have been polished, because most of them don't hold a story which is immediately relevant. But when I cracked this one, I knew there was a different colour there, so it's just like, great, let's explore it a little bit more.
Well,
and that's
funnily enough, we've got a couple of days left on the dig, and I've got a couple of days left in the quarry, and I might possibly be having a look for some of these. Thank you so much for coming along and talking to us, Steve, and telling us all these things. Thank you very much for your big top. Thank you also for all the things you've been doing, and I can't wait for the entertainment that you've got planned. We are almost at the end of a 3-week dig. Do keep looking at our videos. We're trying to upload them as often as we can so you can experience the dig with us, and you will meet more people like Steve who have the expertise in various areas, and also other participants who are taking part in the dig. So keep following, and the hashtag is TUSForce.